Imagine, if you will, a highly profitable, sprawling global enterprise, like a massive company.
Right, something on the scale of a Fortune 500.
Exactly. It has these massive marketing campaigns running around the clock. It has a dedicated treasury department managing millions of dollars in highly liquid assets.
Wow.
Yeah, and it has a rigorous security team constantly auditing the infrastructure, plus a development team that is aggressively shipping new code every single day.
Sounds like a pretty standard, albeit highly successful corporation.
It does, right?
Yeah.
And the revenue it generates is just staggering. But there's a twist here, a pretty radical twist.
Okay, I'm listening.
If you walk into the metaphorical headquarters of this enterprise, you are going to notice something missing.
What's that?
Well, there is not a single desk. There is no coffee machine in the break room. There are no performance reviews, no sick days, no HR disputes, and absolutely no humans.
None at all.
None. Every single role, from the CEO setting the high-level corporate strategy down to the QA engineer testing the code, all the way to the social media manager responding to angry tweets on the timeline, it's all entirely autonomous software. You are looking at a true zero-human company.
It's wild. It sounds like the premise of a dystopian science fiction novel, honestly. Or, maybe a highly theoretical thought experiment from a university computer science lab.
Yeah, totally.
But what we are looking at in our source materials today proves that this concept is rapidly transitioning from a white paper theory into an actual operational reality.
It's happening right now.
It is. We are moving entirely past the theoretical and right into the execution phase.
Okay, let's unpack this. Because our mission for this deep dive is to go through a massive stack of architectural blueprints, real-time system dashboards, project transcripts, and visual schematics.
It's a mountain of data.
It really is. And it's all centered around an ecosystem called Denarii DFi and something they refer to as the Paperclip AI Orchestrator.
Right, the Paperclip Orchestrator.
I have this stack of documentation sitting right in front of me. And, the sheer scale of what is being built here is just staggering. It completely flips the script on what a company even is.
It fundamentally redefines it.
It does. And for you listening right now, whether you are an entrepreneur, a software developer, or just someone insanely curious about where the economy is heading, this is literally a blueprint for the next decade.
Absolutely. It's essential context for where we're going.
But before we get into the nuts and bolts of how a machine actually runs a company, we need to set the stage. Like, why is this happening now?
Well, what's fascinating here is the underlying philosophical shift driving this entire architecture. To really understand the gravity of these blueprints, we have to look at the foundational context of the internet and Web3.
Okay, lay it on me.
So, for over a decade, the entire Web3 space, cryptocurrency, blockchains, decentralized finance, has been almost entirely dominated by speculation.
Right. Buying low, selling high.
Exactly. It has been a world of token-focused narratives, boom and bust hype cycles, and highly human-centric user interfaces.
Just people buying digital assets and hoping they go up in value.
Yeah. But the core thesis of this Denarii DeFi blueprint is a structural realignment. It boldly asserts a new mantra, which is that execution beats narrative.
Execution beats narrative. I like that.
Powerful. We are looking at a transition from simply holding static digital assets to programming dynamic digital behaviors.
Digital behaviors. That is a really distinct way to frame it.
It is, isn't it?
So instead of an asset just sitting statically in a digital wallet waiting for a human being to remember to log in, click a button, and do something with it, the asset is actively participating in the economy on its own.
That captures the essence of it perfectly. The internet is undergoing a fundamental baseline shift. Think about Web 1 and Web 2.
Okay.
It has primarily been a communication layer. You write an email, hit send, and I read it. You post a photograph, I look at it, we communicate.
Right, human to human.
Exactly. But now, the internet is moving toward becoming an invisible execution layer. The blockchain is no longer just a decentralized ledger where we record who owns what.
What are they then?
It's acting as the baseline security and trustless accounting layer for self-operating software. Machine economies are the inevitable step two.
Wow.
And in this new paradigm, value isn't passively held. It is dynamically executed across automated decision flows without ever asking for permission.
So to put that into perspective for our listener, the message buried in these blueprints is incredibly blunt.
Oh, it doesn't pull any punches.
It basically says if any workflow in your business still requires manual human coordination, it is now considered a legacy construct.
A legacy construct.
Like if your system requires a human manager to log in, click approve, or send a follow-up email to confirm a transaction, your system is already outdated.
The documentation actually has a specific, somewhat ruthless term for that. They call it structured inefficiencies.
Structured inefficiencies.
Wow.
Ouch.
Yeah. Every single time a human has to intervene in a digital process, every delay between a digital intent and a digital settlement represents economic leakage.
Because it slows everything down.
Exactly. It degrades the efficiency of capital. If it takes 3 days for a human to approve a wire transfer, that capital is asleep for 3 days.
Right, it's doing nothing.
The innovation we are unpacking today isn't happening on the surface layer where regular users can see it with flashy graphics. It's happening deep down at the coordination layer.
The invisible infrastructure.
Yes, the invisible plumbing.
But looking at these schematics, I immediately hit a conceptual roadblock. I mean, to actually run a global company entirely via code, you can't exactly use a traditional legacy bank.
No, definitely not.
A bank that closes its doors at 5 p.m. on a Friday and takes 3 business days to clear an international wire transfer is going to completely bottleneck an AI that thinks in milliseconds.
It would completely break the system.
Right. You need financial rails that operate at the speed of an API call.
If we connect this to the bigger picture, you've just identified the primary hurdle of automated economies. Traditional finance is simply too slow and too restricted by human operating hours to support a machine workforce.
So how do they fix it?
Well, this is where we get into the actual engine of this operation. The sources detail how Denarii DeFi solves this bottleneck by unifying 3 distinct distributed ledgers.
3 of them.
Yeah, they refer to this architecture as the Trinity of DLT distributed ledger technology. They are attempting to solve the classic blockchain trilemma by not relying on just one single network.
Okay.
Instead, they weave together the XRP Ledger, Algorand, and Hedera Hashgraph into a single, unified cross-chain control plane.
Okay, I have to push back on this a little bit, because looking at this from a development standpoint,
Yeah.
isn't juggling 3 entirely different blockchains an absolute nightmare?
Oh, it sounds terrible.
Right. I mean, every chain has its own coding language, its own consensus mechanism, its own quirks. Why not just pick one really good blockchain like Ethereum or Solana and build the entire zero-human company there?
It's a valid question.
Reading through this, it feels like a company deciding they need to hire a high-speed courier on a motorcycle, an unforgeable government notary, and a master filing clerk, all working simultaneously just to send a single business letter.
That analogy, the courier, the notary, and the clerk, is actually incredibly accurate to how the system functions.
Really?
Yes. And yes, if a human developer were manually managing those 3 networks simultaneously, it would be an absolute nightmare of complexity.
I'd imagine so.
But the Denarii DeFi control plane abstracts all that complexity away from the user and away from the autonomous agents themselves. The orchestrator handles the routing.
Oh, so it's invisible to the agents.
Exactly. They use each of these 3 specific chains for their highly complementary, mathematically distinct strengths. It's about using the perfect tool for a specific microtask.
Okay, well, let's break down those strengths using that analogy, starting with a high-speed courier on the motorcycle, assuming that is the XRP Ledger.
Let's look at the specifications. The blueprint utilizes the XRP Ledger, or XRPL, primarily for its high-speed value transfer. We're talking about sub-second consensus latency.
Wow, sub-second.
Yeah. When an AI needs to move capital, it happens almost instantly. Beyond speed, XRPL provides native decentralized exchange liquidity and incredibly robust trust line configurations.
Okay, so it's the financial pipeline.
Right. In this ecosystem, XRPL uses the native DFI token and integrates directly with non-custodial wallets, specifically referencing the Zaman wallet.
Got it.
So when a corporate AI agent needs to move money across the globe instantly or execute a rapid arbitrage trade before the market shifts, it deploys the XRPL courier.
Fast liquid money movement. Makes sense. But then we have the unforgeable government notary. Looking at the notes, that role goes to Algorand. Why on earth does an AI need a notary?
Algorand operates on a pure proof-of-stake consensus mechanism, but its absolute core feature for this specific architecture is mathematical transaction finality.
Yeah.
Yes. Finality on Algorand occurs in roughly 3.3 seconds. But more importantly than just speed, it has 0 fork risk.
Okay, let's pause there, because fork risk and finality are heavy jargon. What does that actually mean in the context of an AI trying to run a business?
Sure. Think of a blockchain fork like a train track that suddenly splits in two directions, creating two alternate versions of reality.
Okay.
On some older blockchains, if two miners solve a block at the exact same time, the network temporarily splits. You might have a transaction that says you paid for an asset on track A, but on track B, the money is still in your wallet.
That sounds chaotic.
It is. Eventually, the network resolves this and one track is abandoned, but for a few minutes, there is uncertainty.
And I imagine a machine operating at lightning speed cannot function if there's even a tiny percentage chance that its payment might exist in an alternate reality that gets erased 5 minutes later.
That is exactly the issue. A machine cannot operate efficiently if its baseline reality is shifting. It cannot proceed to step 2 of a business plan if step 1 might be rolled back by the network. It needs absolute mathematical certainty that a transaction is permanent before it moves on.
And Algorand gives it that certainty.
Yes, Algorand provides that absolute certainty. The moment the block is written, it is final forever. No forks.
Wow.
The Denarii system utilizes a specific Algorand standard asset. They list ASAID 897649551 managed through the Para wallet to handle these automated, mathematically guaranteed machine-to-machine micropayments.
Okay, so the AI moves the money instantly with the XRPL courier. It mathematically guarantees the contract is permanent with the Algorand notary. So what does it need the Hedera master filing clerk for?
Hedera isn't technically a traditional blockchain at all. It utilizes a structure called a directed acyclic graph, or a DAG, to achieve its consensus.
Okay, more jargon. What does it do?
What Hedera delivers is incredibly high throughput and sub-second latency specifically for data logging.
Data logging.
Yes. In a corporate system run entirely by autonomous AI agents making millions of micro-decisions every single hour, you absolutely must have a verifiable, immutable audit trail.
For accountability.
Exactly. If something goes wrong, human overseers need to know exactly why the AI made a decision.
They need to check the receipts.
Right. Hedera, utilized alongside the Hashpack wallet, serves as the ultimate unalterable logbook for every single agentic decision made across the entire network.
It really is a brilliantly complex architecture. It's using the best parts of 3 different technologies to create a perfect environment for machines to thrive.
It was remarkably elegant.
And it's fascinating to look at the historical context provided in the source notes, because this system wasn't just spun up overnight by a massive corporation.
Not at all.
The notes show that the chief technology officer, Kashif B., and the project coordinator known by the handle website developed 95 actually started building the foundations of this back in the 2021 bear market.
A very tough time to build.
Right. And ironically, it didn't start as a massive high-finance AI orchestrator. It actually had its roots in esports integrations, working with entities like GamerJabus and GJTV.
That evolutionary path is crucial to understand because it speaks to the resilience of the architecture.
How so?
Well, they started by building utility-driven asset frameworks during a massive crypto market downturn. That is a time when the speculative hype had completely evaporated, the tourists left, and only the hardcore builders remained.
They survived the crash.
Exactly. They slowly evolved their architecture from managing simple digital assets in competitive gaming ecosystems into a general-purpose cross-chain AI control plane.
So they built the roads before there were any cars.
That's a great way to put it. They essentially built the underlying unglamorous plumbing for years before they ever introduced the artificial intelligence that would eventually flow through those pipes.
Which brings us perfectly to the brain of this whole operation. We had the high-speed, multi-chain financial rails. The money and the data can move at the speed of light. But who, or rather what, is actually making the executive decisions on where that money goes? I'm looking at the blueprints for the Paperclip AI Orchestrator.
The Paperclip AI Orchestrator acts as the cognitive runtime of the entire network.
The cognitive runtime.
Yeah, it is an open source platform built on Node.js and React, but it is not just another chatbot interface.
Okay, so it's not like ChatGPT.
No, it doesn't just let you chat with a bot to write an email. It takes various powerful large language models, or LLMs, and organizes them into a rigid, highly structured corporate hierarchy.
This is where my mind was completely blown reading these sources.
It's quite something.
They literally assign distinct traditional corporate roles to different AI models based on the specific strengths of those models.
That's right.
So, according to the blueprint, you might have a model like Claude Opus sitting in the CEO agent chair. Its entire prompt and existence are dedicated to setting the high-level strategy and ensuring global system alignment.
The big picture stuff.
Exactly. Then, answering to the CEO, you have Claude Code acting as the engineer agent, actively writing and deploying software.
The builder.
Right. And then you might have an entirely different framework, like Playwright, acting as the QA agent, independently auditing and testing the code the engineer agent just wrote.
It is the literal functional realization of the zero-human company. And it solves a massive bottleneck in current multi-agent development.
What bottleneck is that?
Usually, if a developer is trying to use AI to build something complex, they find themselves juggling dozens of disconnected terminal windows.
Yeah.
The coding bot doesn't talk to the strategy bot.
Right, they're all siloed.
Exactly. Neither of them share context with the marketing bot, and none of them know what the actual corporate budget is. Paperclip sits above all of them as a stateful coordination layer, forcing them to communicate up and down a corporate chain of command.
And it is not just a theoretical white paper. I mean, the real-time dashboard stats provided in these sources are absolutely staggering.
Let's hear them.
Listen to these numbers. We are looking at 128,742 active autonomous agents currently operating in this ecosystem.
Over 100,000.
Yeah. They have autonomously executed over 9.8 million cognitive and operational tasks. And the financial value processed by these bots, over $2.47 billion in on-chain transaction volume.
Billion with a B.
Billion. And the metric that really stands out to me, 100% system uptime.
That 100% uptime metric is exactly the economic driver behind why the transition from human to machine labor is occurring so rapidly.
Because machines don't sleep.
Exactly. They do not sleep, they do not take federal holidays, they do not get jet lag, they execute continuously across global time zones.
It's a relentless workforce.
However, to achieve that kind of cohesive long-term operation, the architects of Paperclip had to solve a fatal foundational flaw inherent in almost all standard large language models.
Okay, I know what this is.
In the documentation, it is dramatically referred to as the Memento Man problem.
The Memento Man problem. I love that name. Because basically, AI models have total debilitating amnesia.
Precisely. The underlying architecture of standard LLM APIs is inherently stateless.
Stateless meaning what?
What that means is every single time you send an API call to an AI agent, it wakes up from a deep sleep with all of its baseline capabilities.
Yeah.
It still knows how to write Python. It still understands macroeconomic theory.
Right, the general knowledge is there.
But it has zero situational memory. It has absolutely no idea what it did 5 seconds ago, let alone what the overarching business strategy for the quarter is.
Wow.
Waking up with total amnesia between every single cognitive thought is obviously disastrous if you are trying to run an ongoing, cohesive global business.
I couldn't help but picture this like that Adam Sandler movie, 50 First Dates.
That is exactly what it's like.
Right, but instead of a romantic comedy, it is a high-stakes corporate boardroom. Imagine your highly paid CEO walking into the headquarters every single morning, sitting down at the head of the table, and having absolutely no idea what the company sells, who the employees are, or what was discussed the day before.
It would be pure, unadulterated chaos.
Pure chaos. So if these models naturally have amnesia, how does the Paperclip Orchestrator actually cure it?
The engineers designed 2 primary mechanisms to force statefulness, meaning persistent memory and context, onto a stateless system.
Okay, what's the first one?
The first mechanism is the heartbeat check-in system. Think of it as a recurring, mandatory loop. Before an agent is allowed to execute any action whatsoever, before it moves a dollar or writes a line of code, it is forced by the Paperclip system to read a highly structured checklist.
Like a morning briefing.
Exactly. This checklist reestablishes its designated persona. It reviews the overarching organizational goals, it tracks its current assignment status, and it establishes a very clear mathematical definition of success for the immediate micro-task at hand.
So the AI literally has to read a briefing document on its own identity and purpose every single time its heart beats before it is permitted to send an email or route treasury funds.
That's right.
It's forcing it to remember who it is.
It acts as an absolute anchor for context. But a heartbeat checklist is only sufficient for immediate context. It isn't enough for long-term project management or historical referencing.
Right. You need a bigger memory bank for that.
That is where their second mechanism comes in, the PRA memory system.
PRA, what does that stand for?
It stands for Projects, Areas, Resources, and Archives. It is essentially a localized, file-based memory architecture.
Because you can't just feed the entire 5-year history of the company into the AI's prompt every single time you ask it a question, right?
No, absolutely not.
The context window, which is the maximum amount of text the AI can process and hold in its short-term memory at once, would get overloaded and diluted instantly. It would be too expensive and too slow.
That is known as the context window dilution problem, and you've hit the nail on the head.
So how does PRA fix that?
By structuring the AI's memory through the PRA method, agents can selectively write to and read from a highly organized, persistent filing cabinet on the local system.
Ah, like pulling specific files from a drawer.
Exactly. If the engineer agent is working on a new smart contract, it doesn't load the company's marketing history. It only pulls the specific strategic files, code bases, or deployment metrics it needs for that specific current task from the projects folder.
Makes sense.
When it's done, it saves its work back to the archives. It allows the entire system to maintain a continuous, evolving operational history across thousands of individual sessions without bloating any single model's active token count.
Here's where it gets really interesting.
Oh, definitely.
With the amnesia permanently cured and the corporate leadership hierarchy firmly in place, what actual tangible work are these 128,000 active agents doing out there on the network?
Right. They have to produce value.
Because they aren't just sitting around in a digital boardroom theorizing. They are actively, systematically replacing human jobs across what the blueprint defines as the 5 pillars of enterprise automation.
This is the core economic value proposition of the entire ecosystem. The orchestrator isn't a toy.
Definitely not.
It is designed to systematically replace legacy software-as-a-service tools, expensive manual administrative agencies, and bloated operational platforms.
So it's coming for human jobs.
Yes. The internal metrics claim it eliminates up to $100,000 in operational overhead for a business, while simultaneously maintaining that 2047 execution. Let's examine how they break down these 5 functional domains.
Let's do it. I want to look at exactly what jobs are on the chopping block.
Okay, let's look.
The first domain they list is SafeX campaigning and social automation. From reading the description, this is basically the death knell for the traditional public relations agency and human social media management teams. It claims to entirely replace platforms like HubSpot, Buffer, and Hootsuite.
It does. The autonomous marketing agents operating within this domain do much more than just schedule tweets.
What else are they doing?
They scrape social platforms continuously, analyzing sentiment in real time. They engage organically with target audiences, deploy highly context-aware content, and execute viral lead generation campaigns completely without human input. They track emerging narratives in the broader market and actively intercept trending decentralized finance topics with brand-aligned messaging.
And financial impact listed in the blueprints is incredibly specific. It claims to save up to $8,120 per month in marketing overhead alone.
That's a massive saving.
It is. You are shifting from paying human beings to manually brainstorm, draft, seek approval, and schedule posts to a system that automatically generates the optimal outcome based on real-time data flow.
Let's take that a step further into the technical realm with the second domain. Automated code and smart contract audits.
Okay, audits.
In a traditional software company, a bug might cause an app to crash. In a Web3 machine economy, a software bug isn't just an inconvenience.
What is it?
It represents a direct, critical financial vulnerability. A poorly written smart contract on a blockchain can be exploited and drained of millions of dollars in a matter of seconds.
Right. So normally a Web3 company would hire expensive, highly specialized human security consultants or external audit firms, which takes weeks and costs a fortune.
A literal fortune.
But this system deploys specialized developer agents, like that QA agent we mentioned earlier, to continuously scan the code. The documentation says they were looking for specific vulnerabilities like reentrancy logic flaws, integer overflow or underflow risks, and access control issues.
Yes.
I want to pause here because that is deep cryptography jargon. Let's translate that. What is a reentrancy flaw?
I'm glad you brought that up because understanding the threat illuminates the value of the AI.
Okay, give us an example.
Imagine you walk into a traditional bank to withdraw $100. You hand the teller your slip. The teller hands you the $100 and then turns to their computer to deduct $100 from your account balance.
Standard procedure.
But before they can type it in, you aggressively hand them another withdrawal slip for $100. Because they haven't updated the ledger yet, they look at your balance, see you still have funds, and hand you another $100.
Oh, I see.
A reentrancy attack is exactly that, but executed by malicious software at the speed of light, constantly requesting funds from a smart contract before the contract can update its internal balance.
That is terrifying. It drains the entire vault instantly.
Instantly.
And the human auditors have to comb through thousands of lines of code to spot a loophole like that. But the AI agents do it automatically, and they also optimize gas consumption before anything touches the mainnet. Gas just being the transaction fee you pay to the network, like digital postage, right?
That's a great way to describe it.
So the AI makes the code cheaper to run.
Correct. And the cost reduction for the company is massive. Replacing those external human security audits saves businesses between $10,000 and $50,000 per single audit run.
Per audit.
Yes. Furthermore, the machine audits happen instantly and continuously with every single line of code written, whereas human audits take weeks to schedule, execute, and return a report.
Which brings us to the money, the third domain. Treasury, DAX, and liquidity monitoring.
This one is huge.
This feels like the actual financial heartbeat of the zero-human company. The documentation states this entirely replaces premium blockchain analytics subscriptions, like Nansen and Dune.
It does. The Treasury agents operating in this domain are conducting real-time, microsecond tracking of total value locked, or TVL, across multiple blockchains.
Okay.
They are monitoring the network for massive whale wallet movements that might indicate a market gump. They continuously audit Oracle price feeds for peg drift.
Peg drift, meaning they ensure the external data feeds telling the system the current price of Ethereum or Bitcoin are actually accurate and haven't been manipulated.
Exactly. And perhaps most profitably, they execute automated arbitrage trades.
An arbitrage trade being when an asset is priced differently on two different exchanges at the exact same time, right?
Exactly. If a price spread opens up across two decentralized exchanges, say, a token is a fraction of a cent cheaper on exchange A than on exchange B, the quant agent spots that inefficiency.
And then what?
It instantly routes the company's liquidity to buy on A and sell on B, capturing that risk-free profit.
Which saves the company up to $5,250 a month in analytics subscriptions and manual accounting. And it does it with zero human delay.
Zero delay.
If an arbitrage opportunity exists for exactly 3 seconds before the market corrects itself, a human trader clicking a mouse is never, ever going to catch it.
Never.
The quant agent catches it every single time. 2047.
That brings us to the fourth domain, Agent Council Strategic Consultation.
Oh, this one is fascinating.
From an organizational psychology standpoint, this one is perhaps the most conceptually fascinating because it replaces traditional management consultants and C-suite brainstorming.
Which we usually think of as uniquely human.
Exactly. High-level strategic planning has almost always been viewed as a uniquely human domain, relying on intuition and experience.
But the blueprint outlines a literal multi-model jury. Say the zero-human company faces a strategic dilemma. Maybe a new regulation just dropped. The system initiates an agent council.
Right.
You literally watch the CEO agent whose prompt is focused strictly on global alignment and corporate governance, debate live in a text channel with the quant agent who is focused strictly on mathematical yield and risk vectors.
It's incredible to observe.
And then the social agent chimes in with an analysis of how the public and other developers will perceive the optics of the decision. They actually debate each other to form a programmatic consensus.
They are continuously evaluating business strategies, assessing regulatory compliance frameworks, designing complex tokenomics models, and even drafting intellectual property roadmaps.
All autonomously.
All autonomously. By utilizing a collaborative, multi-model jury where models with different directives challenge each other, the business receives balanced, multi-perspective guidance instantly.
And what's the financial saving there?
This advisory framework claims to save enterprises upwards of $50,000 per year in human consulting fees and completely removes human ego from the boardroom.
Removing human ego is probably worth more than the $50,000.
You're probably right.
And finally, the fifth domain. Project ticket and delegate orchestration. Goodbye JIRA, goodbye Asana, and goodbye to human scrum masters constantly asking developers for status updates.
The orchestrator parses the high-level product goals decided by the Agent Council and automatically decomposes them into individual bite-sized engineering tasks.
It breaks it down.
Yes. It then dynamically matches those specific tasks to the skill profiles of the available agents in the workforce. It maps the dependencies, identifying which task must be completed before the next can begin, monitors how fast the code is being written, and even compiles automated, highly detailed post-mortem analyses when a system update inevitably fails or succeeds.
It's the perfect middle manager.
It removes all human management friction, yielding up to $100,000 per year in administrative savings alone.
When you zoom out and look at all 5 of these domains operating in tandem, you really see what the documentation means by the competitive edge shifting.
The whole landscape changes.
As you mentioned earlier, the advantage in modern business is no longer about who has access to the most information. Thanks to the internet and LLMs, everyone has the information.
True.
The true, undeniable advantage is orchestration.
That is the crux of the paradigm shift. Economic value is flowing directly and aggressively to the systems that eliminate the friction of human communication chains.
Think about a standard corporation. If my human-run company has to schedule a 2-hour Zoom meeting next Tuesday to decide on a marketing strategy, then draft it, send it to legal for review, and manually deploy it.
You're already too late.
Exactly. And meanwhile, your zero-human company's agent council detected a market trend, debated the strategy, generated the secure code, and deployed a multi-chain financial product globally in 4 seconds.
So 4 seconds versus 2 weeks.
My human-run company will invariably and permanently lose the market share.
Absolutely.
But wait, I have to stop here and sound the alarm. Because as incredible as this sounds, it also sounds incredibly brittle.
How so?
If these autonomous agents are doing all of our marketing, executing our high-speed financial trades, auditing our security architecture, and deciding our overarching corporate strategy completely on their own, aren't we just automating ourselves into a massive high-speed disaster if an AI happens to hallucinate?
It's a very real concern.
I mean, we've all played with chatbots. We've all seen them confidently give completely wrong, fabricated answers. If a chatbot does that while writing a poem, it's funny.
Right.
If a chatbot does that while holding the cryptographic keys to a $100 million corporate treasury, that's catastrophic.
This raises an important question, and it is the exact systemic vulnerability the architects recognized. It is meticulously detailed in the section of the blueprint concerning the measurability gap.
The measurability gap.
Yes, the sources actually cite a dual curve cost model, referencing complex economic research out of MIT to explain this precise phenomenon of catastrophic automation.
Let's break down that MIT math because the blueprint gets incredibly specific here, and it's vital to understand the danger before we understand the solution.
Okay, let's look at the dual curve economic model. It compares 2 distinct, diverging operational costs over time.
What's the first curve?
On the first curve, you have the cost to automate cognitive tasks. Because computational power is scaling and AI models are getting more efficient, this cost is dropping exponentially.
It gets cheaper every day.
It is becoming essentially free to ask an AI to do something. Let's mathematically label that cost CA.
CA? Okay, got it.
On the second curve, you have the cost of human verification and oversight. This cost is biologically bottlenecked.
Meaning humans can't suddenly read twice as fast.
Exactly. A human being can only read so many lines of code per minute and think so fast. That cost remains high and static. Let's label that CH.
So the AI gets infinitely faster and infinitely cheaper, but human beings stay the exact same speed and require the exact same salary.
Correct. The divergence between those two curves as automation becomes vastly, unfathomably cheaper than the cost of human verification creates a vast empty space on the graph.
And that space is the measurability gap.
They define this space as the measurability gap, and within that gap lies immense systemic danger.
Why is it so dangerous?
Because the automation is so incredibly cheap to run, human operators face a massive, overwhelming economic incentive to simply deploy unverified systems and cross their fingers.
Because if a company actually tried to hire enough human QA testers to double-check the 9 million tasks the AI workforce is doing every month, it would instantly bankrupt the company.
Exactly. You'd lose all the cost savings of the AI.
So people just skip the checking.
Right. But if left unchecked, this dynamic creates what the MIT researchers and the Denarii blueprint term a hollow economy.
A hollow economy. That sounds ominous.
It is a terrifying digital landscape filled with massive volumes of machine-generated code, automated marketing campaigns, and high-frequency financial transactions that are being processed and executed completely without verification.
Just bots talking to bots blindly.
Exactly. This inevitably leads to compounding errors, hallucination loops, and ultimately catastrophic systemic risk.
And the mathematical example of machine failure they provide in the notes to illustrate this compounding error is genuinely terrifying. I want to walk through this slowly so the listener can truly grasp the scale of the problem.
Let's construct the scenario. Let's say you have a single, highly capable AI agent.
Okay, one agent.
And let's generously assume it operates with an accuracy rate of 95% per step. On the surface, a 95% success rate sounds excellent for a piece of software.
Right. I mean, if I got a 95% on a college exam, I'd be absolutely thrilled. It sounds reliable.
It sounds reliable, but in an autonomous, unsupervised workflow, errors do not isolate. They compound multiplicatively.
Meaning they multiply.
Yes. If that single agent executes a standard operational sequence of just 10 consecutive steps, relying on its own previous output to guide its next action, you have to calculate the probability of success across the entire chain.
Okay, so what's the math?
Mathematically, you take that 0.95
Okay.
and raise it to the power of 10.
Okay, 0.95 to the 10th power, which means the end-to-end success rate of that simple 10-step task plummets to 59.8%.
Right.
It degrades to barely better than a coin flip just because there was no independent verification along the way.
It's shocking when you look at the numbers.
If that is a treasury agent moving millions of dollars across 10 different cross-chain liquidity pools, a 40% failure rate isn't just an oops moment, it is the immediate end of the company.
Absolutely. So the overarching architectural question becomes, how do they stabilize this fragile system and forcibly close the measurability gap without reintroducing human bottlenecks?
Right, because we can't afford the humans. So how do they do it?
This is where the Paperclip Orchestrator introduces the Independent Quality Assurance, or QA, agent.
The auditor.
Yes. This agent's entire existence, its sole prompt and purpose, is dedicated strictly to auditing the work of other agents at intermediate checkpoints. It does not generate original code. It does not devise marketing strategies. It only verifies logic.
And the introduction of that single independent QA agent completely changes the math of the failure rate.
Drastically. It completely resets the compounding error probability curve.
Let's look at the math again.
If we assume the QA agent also possesses a baseline verification accuracy of 95%, we calculate the chance of a hallucination or error slipping past both agents simultaneously.
Okay.
The chance the first engineer agent fails is 5%, or 0.05. The chance the independent QA agent misses that specific failure during its audit is also 5%, or 0.05.
Okay, I see where this is going.
You multiply those probabilities together, 0.05 times 0.05 times 0.05, and the probability of an undetected error slipping through to the mainnet drops to 0.0025.
That is 0.25%, from over a 40% chance of catastrophic failure down to 1/4%.
It's a staggering improvement.
I have to marvel at how an incredibly simple mathematical principle, just forcing two independent entities to check each other's work before moving forward, is used to save a wildly complex autonomous ecosystem.
It's elegant in its simplicity.
But I still have to push back here, because logic errors aren't the only threat.
No, they certainly aren't.
Even if the QA agent catches the math errors or the hallucinations, we are still granting these software agents full local file system access and network execution rights.
That's true.
What happens if a third-party agent's skill or plugin is actually a deliberately malicious exploit? We've seen massive supply chain attacks in the real world, where a tiny, seemingly harmless piece of code hidden inside an open-source NPM package compromises entire global corporate networks.
We see it all the time.
If an AI agent naively downloads a malicious skill to help it complete a task, it just handed the keys to the kingdom to a hacker.
That is a highly sophisticated concern, and it transitions us perfectly into examining how the Denarii DeFi blueprint secures the physical and cryptographic boundaries of this autonomous workforce.
How do they lock it down?
The engineers are acutely aware of these supply chain vulnerabilities and the reality of malicious state actors. Their solution is a highly secure, automated cryptographic core environment they refer to simply as the Vault.
The Vault. I have to admit, it sounds like something straight out of a cyberpunk heist movie. Ocean's 11, but for algorithms.
Visually, the schematics certainly lean into that dark, fortified aesthetic, but functionally, it is an extremely rigid, uncompromising containment system.
What does it actually do?
The Vault integrates advanced hardware-level and cryptographic safeguards to ensure that multi-chain digital assets are stored and settled entirely by machine logic, but only under mathematically proven, mathematically safe conditions. It acts as an airlock between the AI's thoughts and the actual blockchain.
The first layer of defense they list in the Vault documentation is quantum security systems. Are they really preparing for quantum computer hacks already?
They have to. They're utilizing hardware-level enclave shields and post-quantum cryptographic algorithms.
Wow.
This is designed to isolate the execution environment so completely that unauthorized key extraction or transaction manipulation is theoretically impossible, even against future quantum computing threats that could instantly break traditional encryption. They are future-proofing the vault's door.
Okay, so the machines are locked in a quantum vault, but eventually a human might need to intervene. And to prevent unauthorized human intervention, like a rogue employee or a hacker who stole a password, they use something called biometric blockchain scanners.
Yes, biometric scanners.
The notes say they integrate decentralized identity, or DID, standards with actual biometric hardware checks. Let's clarify that. What does that actually look like in practice?
Think of decentralized identity as a digital passport that you hold, rather than relying on a company like Google or Apple to verify who you are.
Okay.
Now, pair that digital passport with a physical biometric scan, like a fingerprint or a retinal scan on an authorized device.
Right.
If there is going to be a major structural state change in the system, for example, a command to move the entire corporate treasury from the XRPL network over to Algorand, and that specific action requires a human-in-the-loop authorization, a password is not enough.
So they can't just type in admin123.
Exactly. That human must be cryptographically and biometrically verified before the system will even process the command.
It creates an unforgeable physical link between the human operator sitting in a chair and the digital execution layer. You can't just steal a password. You'd have to steal the CEO's actual eyeball.
Exactly. It ties the digital action to a physical human trait.
And for dire emergency situations, I see they have integrated something called a Telegram Oracle.
Yes, the Telegram Oracle.
A Telegram Oracle, like the
Yeah.
encrypted messaging app I use on my phone. How does that stop a hack?
Exactly like the app. It functions as a highly secure, encrypted command relay interface. It translates off-chain human intent, like a panic button emergency circuit breaker command, directly into on-chain execution instructions.
So it's a kill switch.
Exactly. If the human operators are sitting at home monitoring the dashboard and they realize a critical, unforeseen flaw is unfolding in the market, they don't have time to drive to a terminal.
I need to stop it now.
Right. They can use the Telegram Oracle to instantly transmit a verified command to halt the autonomous workforce. It freezes the agents in their tracks.
Okay, so the system is hardened against hackers, and the human overseers have a secure emergency brake in their pockets. But what about systemic, real-world black swan events?
The unpredictable stuff.
Yeah, this is what I keep thinking about. If a major traditional bank suddenly fails and freezes deposits, or a global fiat currency plummets due to geopolitics, or an on-chain price oracle suffers a massive manipulation attack, how does a purely digital, zero-human company react to the physical real world collapsing around it?
That's the big question.
Does it just keep blindly executing its marketing strategy while the global economy burns?
This is where the system's awareness shifts from internal logic to external survival. This is where the anti-gravity dashboard and the systemic risk scanner come into play.
Systemic risk scanner.
The system uses the Gemini 2.5 API, which has a massive context window and incredible real-time reasoning capabilities, to continuously scan the broader internet for those exact real-world anomalies.
Like reading the news.
Exactly. It is constantly ingesting news feeds, financial data, and blockchain metrics, looking for oracle depegs. When a token's digital price detaches from its real-world value bank freezes, or sudden macroeconomic glitches.
And when the scanner actually spots a crisis unfolding, what is the automated response?
It immediately triggers the cognitive swarm in the BFT consensus engine.
BFT.
BFT stands for Byzantine Fault Tolerant. This is a concept borrowed from distributed computing, ensuring a system can function even if some of its nodes are failing or acting maliciously.
Okay.
When a global crisis is detected, the orchestrator instantly halts normal operations and spawns several highly specialized, temporary AI personas to deal with the threat.
Temporary personas.
Yes. The documentation specifically names 3 distinct personas that are spun up: the corporate persona, the cypherpunk persona, and the Wall Street persona.
So wait, let me get this straight. Let's role play this.
Okay, sure.
A massive traditional bank fails in the real world. The news hits Reuters. The systemic risk scanner detects the headlines within milliseconds. It then spins up a Wall Street agent who is prompted to think exactly like a ruthless traditional finance broker trying to mitigate fiat risk.
Yes.
It simultaneously spins up a cypherpunk agent who is prompted to think like a hardcore anti-establishment crypto-anarchist who only trusts decentralized assets.
Correct.
And it spins up a corporate agent focused solely on the company's long-term operational longevity. And these three completely distinct AI personas actually debate each other in a hidden server somewhere on how to best hedge the company's funds against this specific crisis.
That is precisely what the BFT consensus engine forces them to do. It initiates a rapid-fire, multi-perspective debate.
It is insane.
The Wall Street agent might argue to move everything to stablecoins. The cypherpunk agent might argue that stablecoins are tied to the failing banks, and they should move everything to native Bitcoin.
And the corporate agent.
The corporate agent evaluates the liquidity needed for tomorrow's operations. They evaluate historical exploit scenarios, they stress test each other's logic, and they debate the risk parameters. And they do this until they reach a mathematically sound, Byzantine, fault-tolerant consensus on the single best hedging strategy.
And once these three AI personas finally agree on the strategy, let me guess, they don't send an email asking for human permission. They just write the code and execute the hedge themselves.
Exactly. Once consensus is reached, they utilize the sovereign contract synthesizer.
Which does what?
This subsystem automatically generates the deployable smart contract boilerplates necessary to execute the strategy. Depending on where the funds need to go, it might write Solidity code for Ethereum virtual machine networks, PySeal code for the Algorand network, or C hooks for the XRPL.
So it codes its own defense.
Instantly. It generates the mock execution call data to hedge the vault's value across multiple chains simultaneously. It happens in milliseconds.
Unbelievable.
Think about the timeline. They analyze a breaking global financial crisis, they debate the philosophical and mathematical response, they write the defensive software from scratch, and they deploy it to the blockchain before human traders on Wall Street have even finished reading the news headline.
That is a completely mind-bending reality to try and wrap your head around. It feels like high-concept science fiction reserved for an elite group of cryptographers locked in a server room in Silicon Valley.
It really does.
But looking at the next major section of the source materials, Denarii is actually doing the exact opposite of keeping this technology locked away. There is a massive parallel initiative running alongside this corporate architecture to hand these exact orchestration tools to absolute non-technical beginners.
Yes. The initiative is called 1 Million Devs, and it is described as a no-code Web3 builder platform.
1 million devs.
Their explicitly stated mission is to forcefully democratize blockchain development. They understand that if they only build tools for the elite, the ecosystem will stagnate.
They need mass adoption.
Exactly. They want to provide the tools, the educational infrastructure, and the direct financial funding to turn anyone with an internet connection into a Web3 founder.
And their stated goal is to onboard 1 million new builders. I want to talk directly to the listener right now. If you are listening to this and you are feeling entirely overwhelmed by everything we just talked about.
And it is overwhelming.
Right. If terms like BFT consensus, cross-chain liquidity, and plain-teal smart contracts make your eyes glaze over, this specific initiative is directly aimed at you. Because the brilliant catch here is that you don't actually need to know how to code a single line of any of it to build a zero-human company.
Not a single line. They have streamlined the entire complex development lifecycle into 5 distinct, highly guided steps, heavily leveraging generative AI to do the heavy lifting of the actual coding.
Tell us about the stack.
The underlying architecture for this builder platform combines Google AI Studio for rapidly generating the front-end user interfaces, the websites and apps that users actually see, and their proprietary anti-gravity system for generating the secure, complex back-end databases and blockchain logic.
I have the 5 steps pulled up here. Step 1 is just logging in securely with your wallet. Step 2 is accessing your personalized builder dashboard. Step 3 is where the magic happens, the AI build step.
That's the game changer.
You literally just generate the front-end and back-end code through plain text conversational prompts. You just type, I want an app that lets people trade digital baseball cards on the XRP Ledger, and the AI writes the code.
That's that simple.
Step 4, you drag and drop the output file to a service like Netlify for free, instant hosting. And Step 5, you actually earn DeFi tokens as a reward for completing educational tasks and launching your build. They pay you to learn.
And they even address the classic blank page problem.
Oh yeah, when you just don't know what to build.
Exactly. Often, a new builder wants to participate in the ecosystem, they want to build something, but they simply don't know what to make. They lack the initial idea. To solve this, the platform offers an AI idea generator. It acts as a flagship onboarding tool. It actively scans the current XRPL ecosystem, spots missing utility or gaps in the market, and proactively suggests viable Web3 applications that a beginner could realistically build over a single weekend.
Wow, it hands you the business plan.
It even auto-generates the project roadmap, the feature list, and the branding logos.
It is the ultimate low-barrier entry point into a highly technical field, and the blueprints highlight several actual functioning community builds that have already come out of this exact ecosystem.
Here's some examples.
For example, there's Moongirl Web3, which they describe as a community-driven builder hub. There's a project called XMeta, described as a DAO-governed metaverse takeover. There's Moonboy Arcade, which cleverly integrates play-to-earn gaming mechanics with XRPL token rewards, and Shiba NFT AI, a meme token that is autonomously evolving into a decentralized gaming ecosystem.
They are incentivizing this ecosystem growth heavily. The dashboard notes over 19 million DeFi tokens have already been paid out to these amateur builders.
19 million, that's a serious investment.
The underlying philosophy driving this massive educational push is referenced multiple times in the visual materials as Darwinian capitalism.
Darwinian capitalism.
The imagery used on the platform is very striking, almost provocative. It frequently depicts a large ostrich with its head buried deep in the sand, while a gleaming, futuristic, agent-driven digital city rises in the background behind it.
Wow, an ostrich. The message is a stark, uncompromising warning to the current global workforce.
Right, the visual metaphor is incredibly clear.
The warning is basically AI agents are taking over software engineering, marketing strategy, and high finance in real time. Do not be the ostrich.
Do not ignore it.
Don't hide from the AI revolution or pretend it is just a passing fad. The future economy belongs exclusively to the people who learn how to orchestrate the AI agents, not those who try to stubbornly compete with them manually. If you are trying to compete with the machine on speed or cost, you have already lost. You have to upskill.
And importantly, that vital upskilling is offered entirely for free within the ecosystem. The curriculum covers foundational Web3 concepts, AI application design, back-end logic generation, and multi-chain deployment strategies, all supported by daily, live community coding spaces.
They really want people to learn.
They are actively, desperately trying to pull as many everyday people as possible into the orchestration layer before the economic gap becomes insurmountable.
And there's always but when we look at systems of immense power,
here it comes.
We have the open source language models, we have the free builder education, we have the no-code drag and drop orchestration tools. But when you look very closely at the architectural blueprint for the actual paperclip orchestrator, the true stateful engine running the elite zero-human companies, there is a massive cryptographic velvet rope guarding the entrance.
Yes. The democratization has its strict limits. Access to the stateful orchestrator dashboard, and specifically what they define as the founder portal utilities, is strictly token-gated, and the threshold for entry is exceptionally, almost prohibitively high.
I want to list what is behind this gate. To get access to the root sandbox environment, to get priority AI security audits, to get zero brokerage fees on your automated cross-chain arbitrage trades, and to connect your agents directly to the high-frequency live FTSO oracles, which are the decentralized price feeds that allow the bots to trade with perfect accuracy. A user must cryptographically prove that their connected Web3 wallet holds at least 2% of the total global supply of the DFI token.
That is correct.
2%.
It is a hard-coded barrier. The system executes a mathematical validation check upon every login attempt. It calculates the holder weight, which is your wallet balance divided by the total token supply. If that mathematical output is less than 0.02, the gate stays permanently shut. There is no customer service override.
So what does this all mean for the ecosystem? We've just spent the last 40 minutes talking about democratizing Web3, giving powerful tools to 1 million new developers, and fighting back against legacy financial systems.
Right.
But the core engine, the actual cognitive machinery capable of running a billion-dollar autonomous economy, requires you to personally own 2% of an entire global currency supply.
I know it sounds counterintuitive.
Isn't that deeply contradictory? Aren't they just replacing the old Wall Street billionaires in tailored suits with a new breed of anonymous cryptographic whales? It feels like the ultimate bait and switch.
It is a sharp juxtaposition, certainly, and a valid criticism on its face. However, analyzing the system design rationale impartially reveals exactly why this specific exclusionary architecture was chosen.
Okay, justify it.
It doesn't stem from malice or greed. It comes down to two foundational, non-negotiable pillars of decentralized network security: Sybil resistance, and strict incentive alignment.
Okay, let's unpack those defenses. Start with Sybil resistance. What is a Sybil attack, and why does a 2% gate stop it?
A Sybil attack is named after a case study of a woman with multiple personality disorder. In computer science, it is when a single malicious entity creates thousands or even millions of fake identities.
Okay, a bot farm.
Exactly, or in the context of this ecosystem, thousands of rogue autonomous AI agents. The goal is to overwhelm the network, manipulate a decentralized governance vote, or drain liquidity pools through sheer volume.
Right.
In traditional Web 2, like on a social media site, you fight this with email verifications or those annoying picture captchas. But in a high-speed, machine-to-machine Web 3 economy where AI can solve captchas instantly, those defenses are completely useless.
So if a hacker spins up a million bots wearing digital fake mustaches, how do you stop them?
The only reliable, mathematically proven defense is extreme economic friction. By hard-coding a requirement that an orchestrator must hold 2% of the total token supply, it becomes mathematically and financially prohibitive for a bad actor to spin up thousands of malicious orchestrator hubs. Because acquiring 2% of the entire global supply just to execute a single attack would cost an astronomical amount of money up front, and the sheer act of buying up that much supply on the open market would skyrocket the token's price anyway, ruining the attacker's profit margins. Exactly. It makes attacking the system economically irrational. And that dynamic leads directly into the second pillar, incentive alignment.
How does that work?
Think about human psychology. If you hold 2% of the entire network's foundational currency, your personal financial well-being is inextricably, permanently tied to the success, stability, and security of that network.
You're literally invested in it.
Deeply. The system design ensures that the most powerful autonomous execution tools, the ability to deploy swarms of corporate AIs to manipulate markets, deploy executable code, and route multi-chain liquidity, are only wielded by deeply financially invested stakeholders.
I see, because those stakeholders have literally zero incentive to destroy or exploit the network. Because by crashing the network, they would be immediately vaporizing their own massive investment. Their greed actually secures the system.
Precisely. It fundamentally transformed the DFI token from a speculative, highly volatile meme coin into a literal, functional infrastructure key. The gate mechanism ensures that the individuals commanding the AI workforce are economically forced to act in the best long-term interest of the system's longevity. As the blueprint rather poetically states in its concluding remarks, the gate stays shut to those who merely stare, yet opens wide for builders who prepare.
That's intense.
It is undeniably a gated walled garden, but the gate is secured by cold math and perfectly aligned economic interest rather than legacy corporate nepotism or geographical privilege.
Wow. Okay, let's take a deep breath and recap the truly incredible journey we've just been on through these blueprints.
It's been a ride.
We started by exploring the death of the speculative Web3 era, the stark realization that passively trading digital assets is over, and the highly profitable era of programming dynamic digital behaviors and invisible execution layers has officially begun.
A massive shift.
We broke down the unified trinity of DLT, showing how Denarii DeFi leverages the sub-second speed of the XRPL courier, the unforgeable fork-free mathematical finality of the Algorand notary, and the immutable audit logs of the Hedera filing clerk.
We examined the inner workings of the paperclip orchestrator, detailing how the mandatory heartbeat system and the localized pair memory filing system permanently cure the inherent amnesia of large language models,
which allows them to step into cohesive, long-term roles as CEO, quant, and engineer agents.
Exactly.
We navigated the terrifying compounding math of the measurability gap, proving that without an independent QA agent auditing the workflow, a simple 10-step AI task rapidly devolves into a coin flip disaster, threatening to create a hollow economy built on hallucinations.
We looked at the quantum hardware defenses and biometric DD scanners protecting the vault, and we explored how the 1 Million Devs initiative is desperately trying to upskill the global workforce using no-code AI tools before Darwinian capitalism leaves them permanently behind in the sand.
And finally, we hit the massive 2% cryptographic wall that keeps the core orchestration engine secure against Sybil attacks.
The technological leap documented across these sources is profound. It shifts the entire competitive landscape of global business. The defining metric of corporate success is transitioning from who has the best, most highly educated human talent to who has the most seamlessly orchestrated, stateful, autonomous systems.
So what is the ultimate call to action for you, the listener, as we wrap up this deep dive.
What should they do?
I urge you, tomorrow morning, when you log on for work, to look closely and critically at your own daily workflows. Look at the software you use, the repetitive emails you send, the multi-department meetings you schedule. Ask yourself, what administrative tasks are you currently executing that are just structured inefficiencies waiting to be optimized and automated by a specialized AI agent?
Because this transition is not a future projection, it is already compiling and executing in real time.
And that reality leads to a rather chilling, but entirely fascinating, systemic concept for us to ponder as we close. If Darwinian capitalism dictates that zero human companies will inevitably, ruthlessly outcompete human-led ones, because they operate 247, with zero administrative friction, zero ego, and near-instant multi-chain execution, what happens in 5 or 10 years?
What do you mean? Take us down that rabbit hole.
Imagine two fully autonomous, multi-agent megacorporations. Neither has a single human employee on the payroll. And because they operate in the same sector, they inevitably go to war over the exact same market share, the same decentralized liquidity pools, and the same target audience. What does corporate warfare actually look like when the combatants are not human executives, but hyper-intelligent cognitive swarms operating at API speed?
It's a terrifying thought. Do the respective agent councils initiate a secure handshake and negotiate a peaceful, mathematically balanced treaty?
Or do their quant agents calculate that a corporate merger is the most optimal path for token holder yield? Or do they simply deploy aggressive, malicious smart contracts and attempt to code each other into absolute bankrupt oblivion in a matter of milliseconds, all while the rest of humanity is fast asleep?
It could happen overnight.
Which brings us right back to the visual we started with. You walk into that sprawling corporate skyscraper, and it is completely, eerily empty. There are no desks. There are no humans shouting on trading floors. There are no visible signs of conflict whatsoever. Just the silent, invisible, relentless hum of servers, executing a global financial war at the speed of light. That is the true reality of the Zero Human Company. Thank you for taking this deep dive with us.